Happy Monday, grade 5s. I have actually put on a mic today. I'm hoping this will be a little bit better. I know one or two of you have said that just for me to speak a little louder, and I am speaking really loud, but I'm hoping this mic will actually just help a little bit more. Okay, so yesterday I'm hoping everyone did really well on their test. I haven't finished marking them, but you will find out your marks soon enough. Today, so as I mentioned in my video yesterday, today, tomorrow, and then Wednesday, I'm going to be recapping the unit previous to this unit that we just finished, so decimals and fractions. So today I'm going to do 2-3 topics, tomorrow I'm going to do 2-3 topics, and then as well as Wednesday. These are mandatory. I do want you to watch them. Now, you may want to just watch and write the notes down. I will post the extra practice questions in our folder so you have some more practice. There will be a check-in every day. So today, after you watch the video, and when you feel confident, you remember everything about fractions and equivalent fractions, then I want you to go do the check-in quiz. Very short, just quick little quizzes every day, so I know that you're ready for that big quiz on Thursday. Okay? So today, and I'll get right into it, I'm going to obviously review the first initial couple topics, which were fractions and equivalent fractions, and understand what that is. So fractions, and I'll just, again, like I said, I'm not reteaching everything, I'm just doing a recap. Hopefully this recap and this review will just kind of bring all the memories back. So a fraction, remember, and ultimately what a fraction is a part of a whole. So as soon as we look at anything less than one whole, whether it's one whole, if I'm looking at a cake, but less than one whole of a cake, maybe half of a cake, as soon as you're looking at less than a whole, you're looking at something that's called a fraction or a decimal. So we'll get into decimals later this week. So a fraction, and I'll put an example, if I put something like this, so right away you know that's a fraction, right? We've got something over something else. So reminder, the top number on a fraction is your numerator, which means it is the, we could just say the part selected. Okay? And then the bottom, if you remember, is called a denominator, which we know is the parts in total. So what this means in total. So for example, if I got 1/3, which is 1/3, and I said, I know that tells me the top part, I have chosen one part, and that there's 3 in total. So that tells me that maybe if I've got a chocolate bar maybe, that chocolate bar is divided into how many parts? So we know that there are how many total parts? We know that there's 3 total parts, because that's my denominator, which is the total parts. There's 1, 2, 3 total parts. And then my numerator tells me how many are chosen, or how many are shaded or selected. So in this case, it's 1. So that tells me I need to shade in 1. So this would be 1/3, right? And I'm going to write this down so we know how to say that, 1/3. Okay, quick review on fractions. So we know that anything that less than a whole, top is a numerator, which means it's your part that's selected or you're chosen. Bottom, which is the denominator, that means how many parts in total. This is an example of one, right? 1/3. Now, let's say, and just so you remember the wordings, anything, and I'll always, anything over 2 is what? Half. Anything over 3, so I'll just say any number, right? Any number over 2, any number over 3 is third. Any number over 4 is fourths, right? Any number over 5, fifths, right? Hopefully that's coming back, right? Anything over 6 would be sixths. So if it was 3 over 6, we could say 3 sixths, or 3/6, that's still fine. Just a quick reminder of that. Okay, and also with 4, remember it could also be quarters, right? There's an R. Quarters, right? There's a little R in there, quarters. I mean, there's 4. If I had 3/4, it could be 3/4 or 3/4, right? Okay, that's a quick review on fractions. Hopefully nothing brand new. Then we looked at, and And if you ever want to pause the video, pause the video. If you want to just quickly recap, look at your math notes for that lesson, it's up to you. So after fractions, that's after we did our intro, then we looked at equivalent fractions, which is probably one of the most, the most important topic of this unit, which was equivalent fractions. Oh, sorry. Equivalent fractions. Now, and it's in the word, hopefully, equivalent, if you remember, sounds a little bit like equal, right? Equivalent, equal. And that's what it is. Equivalent fraction are any two or more, could be 2, 3, 4, fractions that are the same but look different. So think of like synonyms, right? In English, when we talk about synonyms, there are words that look different, are different words, but they mean pretty much the same thing. That's what equivalent fractions are. Two or more fractions that look different, but they mean the same thing. They represent the same sort of a fraction. So what does that mean? So for example, different color. If I had, okay, I'm gonna draw that chocolate bar, okay? So right now, same two chocolate bars. So you have one and your sibling has one. Same size, okay? One is not smaller, it's the same one, same packet your mom bought for you is the same packet your dad bought for your sibling, okay? Now, if I had, right now, let's say the chocolate bar comes in fours, okay? And let's say your mom gave you this, and so far this morning you had one big chunk. So how would we represent this as a fraction? I would say that's 1/4, because one section is shaded, and there are how many in total? 4. That is correct. Now, let's say your sibling wanted to save and didn't want to have that big of a chunk. So your sibling took the same chocolate bar and maybe made into smaller pieces. She didn't want to have that much chocolate. Since she just wanted to have, smaller chunks in the day. So she wanted to have smaller chunks. Now, she had the same amount as you, but she wanted to eat them in smaller chunks for whatever reason. She wants to enjoy it for longer. Now, that isn't 1/4 anymore. Now, what is it? Because now there's 2 sections that are shaded in. And how many are in total? 8. So, fractions that look different, but they represent the same portions. So these are equivalent. These are the same. It just looks different. Fraction looks different. Denominators are different. Numerators are different. But our picture, if we do as a picture, it's the same. This chunk is the same as this chunk. Think of a manufacturing company that makes, I don't know, an Aero bar or a Snickers bar. It's the same bar for me. It would be a same Snicker bar for my sister, right? Now, that's what an equivalent fraction is. Fractions that look different, but they are the same thing. Now, and that's a visual representation. Now we need to know how to calculate equivalent fractions. So, how we do that, and for that, again, you just need to know your multiplication facts. If I gave you, I'll just do a few examples. If I gave you, let's say 3/10, okay? And I said, make an equivalent fraction 50. So I said, what is the equivalent fraction to 3/10 and something over 50? So you're thinking, okay, your think bubble, your thought bubble is saying, well, 3/10 is equal to something over 50. Now I don't know my numerator, but I know my denominator. That is fun. Then you just need to do, okay, how did I get from 10 to 50? 10 times what gives me 50? Okay, hopefully this is all coming back. 10 times what gives me 50? This is where your multiplication facts come in. I know that 10 times 5 gives me 50, right? 10 times 5 is equal to 50. If I do something to the denominator, I need to do it to the numerator. If I do something to the bottom, I have to do it to the top. So do the same thing, times 5. What is 3 times 5? 15. There we go. So 3/10 is equivalent to or equal to 15 over 50. They're the same. Look different, but again, if I drew a picture of, maybe a pie cut into 10 and then a pie cut into 50, they would be the same sections. Let's do another one. Let's do it over here, example 2. Let's do 4/12 or 4 over 12 is equal to something over 24. And the same thing, my thought bubble right now, when you try to in your mind, is thinking, how did I get from 12 to 24? 12 times, not 12 plus, not 12 subtract. If we're getting bigger, don't add. Has to be multiplication. We're never adding in equivalent fractions. You're either multiplying or dividing. But if I know my number went up, it's obviously multiplication. So 12 times what is 24? 2. 12 times 2 is 24. If I do it to the bottom, I have to do it to the top times 2. That means it is 8. Okay, easy enough? Let's just do a few more. Now let's say if I had, example 3, if I had 8 over 16 is equal to something over 8. And like I just said, right? Now, again, I'm missing a numerator. I have my denominator, but this time, my fraction or my number got smaller. And like I said just 2 minutes ago, right? You either are multiplying or if the numbers are getting smaller, you are doing what? You are dividing. So 16 divided by what is equal to 8, right? Or if that really bothers you, then just think of the other way. 8 times what is 16, right? So it's 2. You need to divide. Same thing, if I'm dividing it by 2 at the denominator, I need to divide by 2. What's 8 divided by 2? 4. Now you can check, because sometimes I know some of our friends, you're better at multiplication than division, then just check. Do the opposite. 8 times 2 should be 16, yes. And then 4 times 2 should be 8, that's correct, right? This is, now I just flipped it, but this could have been the other way around, right? Because I know this is easier for us to see. 8 times 2 is 16, 4 times 2 is 8. It's the same thing, I've just flipped it. I want you to get familiar with that, right? It's the same thing. Okay, let's just do maybe 2 more, and then we can move on. Hopefully it's all coming back. Let's do this one. Now what if I have, so 2 over 4 is equal to, this time what if I gave you the numerator and I didn't give you the denominator? Use the same strategy, same thing, right? I'm missing my denominator, but how did I get from 2 to 6? 2 times what is equal to 6? 2 times 3 is 6. If I do it to the top, I have to do it to the bottom. So 2 times 3, 4 times 3 is 12. Okay, so it doesn't matter if I give you the denominator or the numerator. It's the same strategy. Okay, maybe let's do one more. Example 5. So I'm doing tons of examples. Hopefully it's all coming back now. Is equal to, again, I'll give you the numerator just so you get comfortable with it because it's the same strategies, right? 3 times what is 15? 3 times 5 is 15. Then I need to do it to the bottom. 5 times 5 is 25. Okay, simple enough. So equivalent fractions, you're never adding or subtracting, you're either multiplying or dividing. And again, I know, maybe I'll do a division. Let me do one with division, just because I know some of us prefer multiplication, or we really get multiplication, but not so much division. This is example 6 now. Ooh, holy moly. If I give you, let's say I give you, okay, let me give you this. Okay, something over 5 is equal to 4 over tenths. Okay, now you're trying to, again, do backwards, right? Now, again, don't get confused. How did I get from 10 to 5? Remember, my arrow is going this way because I'm trying to find out this one. So how did I get from 10 to 5? What did I need to do 10 to get to 5? Because this is my whole fraction that's given. I had to go, to get from 10 to 5, I needed to divide by 2. So that tells me to get this mystery number, I need to divide the top by 2. So what's 4 divided by 2? 2. There we go. But I know some of you prefer your multiplication, so check your multiplication. 2 over 5, 4 over 10. Let's see. Let's check. 5 times what is 10? Times 2. 2 times what is 4 times 2? So that is correct. So you can check your multiplication with your division, right? Your division with your multiplication, in case you prefer one way or another. But remember, the only thing different here was I'm going from this side to this side because I'm missing this information. When I'm missing this information, I go this side. So the arrows, you don't have to draw the arrows. I always tell my kids this. It helps. It's a helpful strategy if you like to do step by step, but you don't have to. If some of us, our mental math is just really, really good. We're just quick, and that's fine. That's okay. Okay, so that's equivalent fractions, right? Two or more fractions that look different, but are the same thing. And then we'll do the last topic for today. So we've done a quick review on fractions, numerator, denominator. We've done equivalent fractions, and then we'll do one more topic. And that'll be our review session for today. And you'll do practice questions and the quiz after this. So let's do one more, which we can say is comparing fractions. This was another big one, comparing fractions. Okay, this was saying which is bigger than or less than or equal to. So those were the 3, and I'll put that maybe here. So we either looked at greater than, less than, or equal to. They're too close. So greater than or less than or equal to. So now, and if you remember when we did this, we looked at three different ways to determine. Now 2 are super easy, and there are little tricks to that, right? So if you have, so one of them could be that you have the same denominator. So if the denominators are the same, do you remember the rule? I know this might be a little bit, you may have forgotten, but if the denominators that are the same, this is the easiest one. So as soon as you see the denominators are the same, the rule is the bigger numerator, and I'll keep this short, is equal to bigger fraction. I'm not writing full sentences for many reasons. One, because I have a small board, but 2, because that would just take way too long. So bigger, sorry, not number, I meant to say numerator. Bigger numerator means it's a bigger fraction. Okay, what does that mean? Let's do an example. So I'm saying, if I have 5 over 7, blank, it's greater than, less than, or equal to 3 over 7. Now in this rule, I have the same what? Denominators. So my denominators are the same, 7 and 7. So this is easy. As soon as you see the denominators are the same, you look at the numerator, which one is bigger? So which one is bigger, 5 or 3? 5 is bigger, right? That means this fraction is bigger. So denominators are the same. You jump to the numerators, whichever one is bigger, that's your greater fraction. Let's do another one. Let's say if I had 3 over 9, something with 7 over 9. Same thing. Denominators are the same. They're both 9 and 9. Perfect. You look at your numerators then. Whichever is the greater numerator, right? Bigger numerator means bigger fraction. So 7 happens to be bigger. And I'll put this in purple. If 7 is bigger, then that means that is the greater fraction. Okay? This one's always the easier one. Just look at whichever one is bigger. Numerator, whichever is the bigger one. Also, a thought bubble, and we can use our common sense as well. Think about it. If I have a pie that is cut in, they're both pies, but they're cut in 9s. This pie, you get 3/9 of them, right? You get 3 pieces of the 9. And with this pie, you get 7 of the 9. Obviously, you get more pie here, right? You're closer to getting almost the whole pie here. Same here. If I have a pie that's cut into 7, and this one, you get 5 of the 7, and this one, you only get 3 of the 7, we know this one is bigger, okay? That's one situation if the denominators are the same, okay? So rule 1 for denominators is the same. The bigger the numerator, the bigger the fraction. Next, situation 2 could be, okay, I'll erase this. Situation 2 could be the following. If you have the same numerator, now what happens? So if my numerators are the same, the rule then is the smaller denominator equals bigger fraction. Okay, now I've reversed it. So now the denominators are the same. So let's look at an example. If I have 9 over 12 and something is equal then greater than or less than to 9 over 10, right? 9 over 10 and 9 over 12. Now, again, my numerators are the same, right? These are the same. As soon as you see numerators are the same, look at the denominator. The smaller the denominator this time, the bigger the fraction. So it's 10 smaller or 12. 10 is smaller, therefore my fraction is this one is bigger. Okay? Same analogy. If I have a pie that's cut into 12 pieces and you get 9, and then I have this other pie that's cut into only 10 and you get 9, this one, you're really close to one whole, right? You're one slice away from a whole here. Here, you're 3 slices away from a whole. So obviously that tells me this one is bigger. I want that pie. This one I would get a little bit less. Next, if I have 3 over 8, I'll do one more of this and then do the last one. So 3/8 and 3/9. Again, my numerators are the same, 3 and 3. Look at the denominators. The smaller the denominator, the bigger the fraction. So which one is smaller, 8 or 9? 8. So we know that this one is bigger. Again, use your common sense. Let's use some application. If I have a pie that's cut into 8 pieces, and I get 3 of them, and this one's cut into 9, and I get 3 of them also, which one is closer to a whole? Which one is closer to one whole pie? This one. You're closer to this one than this one. Okay? That's your rule for same numerator. So those are the 2 easy ones, if you have the same denominator and the same numerator. The last situation, which always requires a little bit of work, not hard work, but you know how to do it, is the following. If you have different, the third situation is you have different numerator and denominator. Now both are different. There's no matchings. And denominator. So, what that means is, for example, if I had 2/3 and 3/9. Your first job is to see, are my denominators matching? Nope. Are my numerators matching? Nope. That's your first. Do that first instantly, just in case. Now, as soon as you see they're not the same at all, then you have to do a little bit of work. Not hard work, just a little bit of work. So, step 1, you have to, and maybe I'll write it down. So step 1, you need to do the, LCMs of denominator. You're probably like, oh my gosh, I remember LCMs. Okay, LCMs of denominator, which is just your multiplication fact. So my LCMs are 3 and 9. So 3, 6, 9, 12, 15, and 9, 18. And I'm going to stop right there because what do you see? Because with LCM, you're trying to find the lowest common multiple. Which 2 numbers are matching in both of the multiplication facts? What do you see? Which one is it? 3, 6, 9, 12. Not right away. You should see that ding, 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 ding. Yeah. 9 are matching, right? They happen to be in both. Then you need to do equivalent fractions. Actually, you know what? I'm going to do this on the next page. Okay? So far, 2/3, I'll leave this. So 9 is my LCM. I'll write that here. LCM is equal to 9. Okay? So step 2, you need to do equivalent fractions. So what that means, I need to make 2/3 equal something over 9. And then I need to make 3/9 equal something over 9. Now let's do this one first because it's easy. It's already a 9. You don't even have to do it. It's already done. This one, and you remember your equivalent fractions, right? How did I get from 3 to 9? You multiplied by 3. If I do it to the bottom, I have to do it to the top. So 2 times 3 is 6. So I've got 6 over 9 and 3 over 9. Which one is greater? Because now the denominators are the same. So which one is greater, 6 over 9 or 3 over 9? So we know 6 over 9 is greater, therefore 2/3 is greater than 3/9. Okay? That's the only difference when you just have to do this two extra steps, LCM and make equivalent fractions, because you can't compare them. Now, again, we can use our application and our common sense. We could have predicted that 2/3 would probably be greater because that is closer to a whole than 3/9, but we do have to show our work. We do need to remember LCMs and equivalent fractions. Let's do one more example like this, because this is the only one that's a little bit, not harder, I wouldn't say harder, because like I said, this is everything we know how to do, but it's a little bit more work. Let's do another example, and then we're done. Example 2. Let's do 1/3 something over 9/10. Okay, now let's predict, let's use our application and prediction skills. Do we think 1/3 is going to be greater or 9/10? Which one is closer to a whole? Hopefully you're thinking this, right? 9/10, we're only one slice away from a whole. This is 2 slices away from a whole. So maybe, and we'll predict, this is probably going to be bigger. But let's show our work, because we always have to, right? Now, I have to first do my LCMs of my denominator, not my numerator, of my denominator. Remember that, my denominator. So I've got my 3, and then I have 10. 3, 6, 9, and probably you're thinking, well, Miss Mavish, I know what the LCM is going to be, right? Sometimes just click in your application skills, right? Your common sense. And we know 30 is the only number that can multiply to get to 3. So, oh, sorry, I'm jumping the gun here. And then ding, 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 30 is my LCM, because that's the only one that matches. Then we do the same thing. 1/3 is equal to something over 30. Let's do that first. So 3 times what is 30? 3 times 10 is 30. That means I have to do it to the top. 1 times 10 is 10. Then do the same thing here. 9 over 10 is equal to something over 30. How did I get from 10 to 30? I multiplied it by what? 3. That means 3 here. 9 times 3, 27. So which one is greater right now? 10 over 30 or 27 over 30? Which one is greater? We know this is greater. Therefore, 1/3 is greater than 9/10. And you can tell our prediction was correct. We were in fact correct. But we have to prove our work, right? Math, you always have to show your work and prove with evidence. So LCM first, which is just your multiplication facts of your denominator. Please don't start doing LCMs of 1 and 9, because you never look at numerators, you look at denominators. And then just equivalent fractions. Again, big review. So that, and I'm going to stop there. That will be our review for today. So a quick review of our review. We looked at fractions, right? What a fraction is, it's part of a whole. You have your numerator and your denominator. And we looked at equivalent fractions. Equivalent fractions basically just mean 2 or more fractions that are the same, but they're represented in different ways. And then we looked at comparing fractions, which could be if you have the same numerator, if you have the same denominator, or if you have nothing the same, and then you have to do your LCMs. Okay, I'm going to post some extra work, just practice sheets on these topics in our folder for today. You have to do a quick check-in today, so I want you to go onto your Edmodo quizzes, do the quick check-in on these 3 topics today. If you've aced it, that means you're ready for that quiz on Thursday. Okay, good luck. I will see you when I see you. Bye.